you so much for joining yet another webinar series on Ethernet by Ansett. And this will be the last webinar for this year. And I hope that you had a lovely year and we look forward to a better year in the coming 2025. Okay. On this note, let me start with something that today. Today we're going to see a very interesting protocol, which is the SUM IP protocol. And let's have a quick look at um, a quick intro about Ansett. Ansett is a automotive electronics company. We started in the year 2007. 17 years of experience working with various semiconductors, tier ones, OEMs, and different other organizations in automotive electronics. And I'm Karthik, and have around 20 years of experience in automotive electronics. So today, what we will try to cover is in this webinar, we will try to cover what is SUM IP. We will also see why SUM IP has become a non-negotiable protocol in the automotive electronics industry, especially with the advancement of software-defined vehicle. We will talk about some of the how SUM IP can be subscribed as a service. How can we use SUM IP as a service? What kind of services are supported by SUM IP, and how do we consume these services? So that's something that we will do. We'll also touch base upon service discovery protocol, and we'll take a use case of a radar example, and we will see how that example can be implemented in a SUM IP. So we've come up with a small tool. We have come up with a tool, and it has come up with its own tool in order to generate the SUM IP stack. Okay, so we'll also run you through a demo on how do you can use the tool to kind of build your stack and test it and things like that. So we'll also give you an infrastructure requirement and take it from there. Okay. So on the in a nutshell, if I have to look at it, SUM IP is more of an application layer protocol. Okay. So when I say application layer protocol, there is nothing much that is present in the presentation layer or in the session layer with respect to SUM IP. It's more of a application layer protocol, and it can be integrated in both the systems. That means it can be integrated in both the microprocessor architecture as well as it is integrated in the microcontroller architecture as well. So classical can in the release after 4.0, SUM IP is a protocol that is being supported as well. So it stands good, and the SUM IP is run on Ethernet. Okay, so it uses the base of the Ethernet protocol. That means because we are talking about automotive, we are talking about 100 base T1 or 10. I'm sorry, 10 base T1 as the physical layer. It's typically an automotive physical PHY that we are going to use, and it will use the hardware address as specified by the MAC layer. We have done a lot of webinars on that. You could refer to the previous webinars on if you want to understand the data link layer and the MAC layer and the other layers. The network layer, it will add in the MAC layer, it will add the hardware address. And in the network layer, it will add the IPv4 address. And in the transport layer, it will add the TCP address. Okay. So on top of it, you have the application. So just like DOIP, okay, just like DOIP, which runs on top of Ethernet, SUM IP also runs on top of Ethernet protocol. Okay, and it's more of an application layer protocol trying to establish communication between ECUs. So the major difference between SUM IP and DOIP, if you look at it, DOIP is more used for diagnostics as a service. So whenever you want to use diagnostics, you use DOIP. But whenever you want to extend communication, we use SUM IP. Okay. So wherever you want to do a service on real time, or you want to transmit data over real time, and when I'm saying transmit data, the data could be also of huge bandwidth, and that is why we are using Ethernet as a packet as the underlying protocol. Then we use SUM IP. Okay. So one of the basic advantages of SUM IP is SUM IP supports an architecture which is typically called as service-oriented architecture. If you look at automotive in general, Automotive in general was not designed for service-oriented architecture. Automotive in general was in specific designed for signal-based architecture. So whenever there's an event happening, this event is shared between different electronic control units, and the other electronic control units use this event or this parameter which is shared by this particular ECU, and they take decisions. For instance, whenever, as a simple use case, if I have to look at it, an event could be as simple as when your door opens, there is a CAN signal which is transmitted by the door ECU, and that in turn turns on the interior light, that in turn turns on your audio system, that in turn puts a display on your cluster saying that your door is open. So these are some effects, and the event is opening of the door. That's how automotive systems were primarily designed to. But moving towards a software defined vehicle where we were supposed to, like, say, support Ethernet. Signal based Ethernet is not designed for Ethernet is not designed for signal based communication or event based communication. Ethernet is more designed towards service oriented applications. Okay, so what do I mean by a service oriented application? Let's say, for example, you take an internet application. Let's say, for example, YouTube as an internet application. Okay, there are, like, say, hundreds of YouTube channels that are available on the internet. Okay, and you as a user, what you could do is you can subscribe to a particular channel, and whenever the channel has an update, then probably you get a notification saying that, hey, there is a update on this particular channel. You want to go ahead and watch it, you go ahead and watch it, or you continue to discard, you can continue to discard. Okay, so this is typically what we mean by a service oriented architecture. Okay, and the advantage of using a service oriented architecture is, when you use a service oriented architecture, only these two parties are talking. The party which wants to access the data, okay, that means the party which is subscribed, the client. There could be thousands of clients, but there could be only two subscribers who have subscribed to that particular YouTube channel. And so the notification comes only to these two subscribers, and only these two subscribers may intend to go ahead and watch the particular video or whatever you call it. So that way, it limits the unwanted traffic flow on the internet. Okay, now just put this on context of a signal based communication like a CAN. Let's say, for example, someone is publishing a video, and this video is, like, say, broadcasted across all the players of the internet, then it's going to be a huge mess, right? So that's not what you want to do it. And similarly, when you brought this into an automotive world, what happens is, today when we are talking about software defined vehicle, and today we are talking about Ethernet architectures, you are connecting your automotive to the external world. And then what happens is, the automotive the ECUs have to, like, say, consume huge amount of data. Like, say, for example, they may have to run some capture the video, they may have to capture the distance through radar, they have to capture what type of image through a radar sensor. Then they may, if it is a near end, they may use an ultrasonic sensor. And then based upon the inputs of all the three sensors, they may have to run a fusion algorithm, and that input could be fed to other systems, like, say, for example, consumers. Like, say, for example, an electronic stability may need this information, adaptive cruise control may need this information, and things like that. Okay, so now the data bandwidth is also going over the roof, and it is very important to like, say, for example, move from what was a service signal oriented architecture, which was more towards broadcasting and lightweighted data, towards subscribing to service and, like, say, transmitting the data as and only necessary, and not transmitting it every time when it is available. So these kinds of service oriented architectures have become mandatory, especially with the globe of today, what we call it as a zonal architecture or zonal computes that are happening in the automotive industry, where we have all these edge nodes. These edge nodes are, like, say, more of microcontroller based systems. Like I mentioned, it could be adaptive cruise control or an electronic stability program, or it could be a ABS sensor, or it could be an emergency braking unit. These are different electronic control units which are run on microcontrollers. And these are, like, say, typically microcontrollers which are capturing the data and feeding it to the HPF. You have a HPC here, typically your high performance computers, which could be the zonal compute doing the high intense processing, running the fusion algorithm and feeding back the data and things like that. So now what happens is there is a marriage that has to happen in terms of two things: a microcontroller architecture, which is, like, say, the edge units like ESP, ACC, emergency brakes, and the HPC, which is going to run the high performance computing. They need to talk to each other. That typically means a microcontroller is going to a microprocessor over Ethernet, okay? Plus, it's going to have a different architecture, which is a service-oriented architecture, not a signal-oriented architecture, okay? So these are two problems that we are trying to solve using some IP. One, like, say, service-oriented architectures, which is going to consume huge bandwidth. Two, it is going to have a marriage between high performance computers which are running on Linux based operating systems or QNX based systems, and a microcontroller based system which will be running on real time operating. It doesn't have a operating system like QNX or Linux. It has a lightweighted real time operating system like an OSEC operating system or an AutoZar OS. So a marriage between these two organizations have to take place. And this has become imperative, especially when we are talking about moving towards software defined vehicle, moving towards HPCs, um, uh, moving towards service oriented architectures, and increasing the complex, moving towards ADAS 5 systems, etc. Okay. So when we come to services, we discussed that we're going to use a service oriented architecture. And in service-oriented architecture, there are different kinds of ways that a client and a server may establish communication. In our example, at this point, let's assume that the high-performance computer is a computer, like, say, for example, it could be a Jacinto board or an NVIDIA board, which is, like, say, uh, having access to, which has got a lot of hardware accelerators, and these hardware accelerators could be running some their own hardware acceleration units, which capture the video, which capture the distance with the help of lidar sensors, which capture the near distances using ultrasonic. And all these information are captured at the hardware level and processed at the hardware level using hardware accelerators, making the compute engine so powerful that it is able to feed the data into your processor, which is running on Linux or QNX based systems in nanoseconds. Okay. And yeah, the HPC is, like, say, running on QNX based system, which is doing the compute, and it has captured the distance. Okay. Now you have your HPC, which has captured the distance between the object and you. It has also identified what is the type of object. Let's assume it's just capturing these two parameters, and these two parameters have to be fed to the other microcontrollers, which are, like, say, adaptive cruise control. Let's just take the adaptive cruise control for our use case, and the microcontroller and the microprocessor are going to talk. Now, when the microcontroller and the microprocessor are going to talk, you can have, like, say, three kinds of discussions. Okay. When I say three kinds of discussions, it could be, like, say, in simple terms, let me put it, it could be, like, say, a group discussion, or it could be like a one-to-one meeting, or it could be like a teacher student discussion. These are, like, say, examples of discussions that you can have, right? When you have two people talking, you can have different kinds of discussions. So similarly, there are, like, say, different kinds of discussions. The first discussion is what we typically called as event-based discussion. When I say event-based discussion, the idea is very simple. the client subscribes to the service. Okay, the client subscribes to the service. What is the service? The service is distance capture. And what is the image? Okay, the service is distance. Let's even now narrow it down to one service, distance. Okay, the service is distance. So the client subscribe to this distance service. So whenever there is a distance getting updated on the fusion algorithm, it informs the clients. Okay, the client, for our use case, we need to kind of say that the client is the ACC, adaptive cruise control. So the client subscribes to the service, and whenever the client service gets updated, which means the distance get updated, it will inform the client saying, a distance has moved to 39 meters, 100 meters, 120 meters. It keeps updating. Or it could also be saying that every 100 millisecond, you kind of report to the client saying that, okay, what is the distance? Depending upon how you want it to behave, you can configure it. Okay, so that's the first kind of service, which we typically call as event-based service. The second service that you can subscribe to is, or the second type of way the client and the server can talk is what we call it as the fields. Okay, in the fields, the client will actually go ahead and read the data from or write the data from the server. Okay, so let us say, for example, you have a service, and say, for instance, you ask the particular guy to get a radar value. Okay, or you say, or get the speed value. Or for instance, you can ask the server to say, set the speed of this particular motor to some value. You can set parameters or get parameters. Okay, so such kind of things where you have direct access to read or write. Okay, you can is called as fields. This is another way that the client and the server can talk. And the third is a method. Okay, so in the third is a method. So the difference between in the field, okay, in the fields method, you don't have to subscribe to an event. Okay, you don't have to subscribe to an event. Similarly, in the methods way of talking, you don't have to subscribe to an event. Okay, but what it works, how it works is, it's like a request response method. Okay, you ask the server to do a service. Okay, you ask the server, hey, turn on the engine, compute the value, and give me the value. Okay, so you can ask the guy to turn on, compute the value. You can also say, don't get the response. Okay, so this whole sequence, okay, of asking him to do a job and getting some work done, and then getting a response from the server, is what we call it as methods. Okay, so in the methods, again, you don't have to necessarily subscribe to an event. Okay, so the only in the first technique of communication, where it is the events method, you subscribe to a event. The other two techniques of communication, which is the fields method and the fields technique and the methods technique, you don't have to necessarily subscribe. Okay, this is like, say, just go get or set a value, and it finishes. Here, it's not about just getting and setting a parameter. Okay, this is like exchange of variables, I would call it. Okay, where you just say, okay, get the vector or set the value and just do it. Okay, you don't necessarily do anything like a function is executed. But here, it's, you are asking the server to do a particular operation, and after it does an operation, you can ask him to return the value. Okay, so that is what we called as methods. So I put the same thing in terms of a picture. Here is your two communication techniques where you necessarily don't have to um, subscribe to an event. Okay, so look at the first technique, which is, I'll look at the right hand side, because in the order of the bullets we put in the get set, you just like say, ask him, get the parameter or set the parameter. You may ask for a response, or you may not ask for a response. That's also fine. Okay, so but probably you ask for a response. Okay, get and set a parameter, get the get the speed or set the speed, and you get a response. Okay, this is what we mean by getter and setter method fields. The method is like, say, you request for an operation, he does the operation, and then he gives you a response. Okay, This is like a client server call in your AutoZar, okay, where you may have to what is it called um, wait, okay, you have to wait, okay, for the response. There is the method can also be just a request. Okay, you say request for the parameter and just do it. Okay, you don't have to necessarily expect a return. It's called fire and forget. Okay, this is actually without return. It's a typo, without return. So you just request and then it does not get a response. You just request for a function to be start. Say for example, just say start the engine and it's over there. You don't have to necessarily expect a response. Okay, so that's the second kind of technique. This is the last technique, which we call it as event group notification, where you kind of subscribe to an event, and whenever there is an event happening, it could be periodically reported, or it could be like say reported whenever there is an updation of the event. Okay, so this is also happening. So these are the three ways a client and a server can talk to each other. Okay,
Uh,
three ways.
can we can we ask questions in between, or it's all at the last?
We'll take it to the last. Yeah, just to kind of.
Okay.
Yeah. So these are the three ways a client and a server are going to talk to each other. Okay. This is typically your protocol format. I'm not going to like say spend time here. We're going to spend more time in kind of seeing how service discovery is done and the process with the help of a tool, which will help you understand better. But typically, every service is associated with a service ID. It has a method ID, which is 16-bit. Okay. And you have a request ID and a session ID. Okay, we'll talk about all these things in detail when the request ID actually talks about the client ID and the session in which he's going to establish communication. So that's something that you could do. And the protocol version, the software protocol version, and the different kinds of interfaces, etc., etc. There's also another interesting part. Okay, the other interesting part is like say even before you kind of subscribe to use talk. Okay, even if before you talk. Okay, the first is you need to from the server side. Okay, from the server side, the server has to publish the service. Okay, saying that hey, I am like say having all these information, so he has to publish the service. And from the client side, what happens is he has to like say subscribe or I mean he has to identify that this particular server is providing the service. Okay. So this particular phase is typically what we call it as the service discovery phase. Okay. And that's an important phase. And only after service discovery happens, then the client and the server can actually start talking. Okay. So in the order of processing, the first thing that happens is actually the service discovery. So in the service discovery phase, what we do is the server actually publishes the service. Okay. So now let us take for example, let's say for example, I have 10. It's a star topology. Okay, it's a star topology, and I'm just going to put it into a context on how a server publishes the service. Okay, so every service is associated with a service ID and an instance ID. Can you see this? I'm going to spend time here. Okay, so it is associated with a service ID and an instant ID, and it also is associated with something called as a time to live protocol. And these are the protocol versions. Let's not worry about it too much. But the service ID, instance ID, and the time to live are three important parameters. So now let's look at it from a server point of view. How does the server intimate all the clients that this service is available? Okay. How does the server intimate to all the clients that this particular service is available? Okay. How it actually does is we will see it on the code, but high level, how it does is whenever a service is created, it is always associated with a service ID and an instance ID. Okay. This service ID and instance ID is here as part of the service discovery protocol. And Once this is available, when the service discovery protocol is completed, what it will do is it will add its UDP address. Okay. In the UDP address, it will add the port address. Okay. You have two addresses in UDP which you can add: source port address and destination port address. Okay. The server will add its source port address. Let's say, for example, the source port address is 8150 as an example. Okay. The destination port address, what it will do is it will add a multicast address. It will add the multicast address. Okay. Right. Similarly, what happens in the network address, whenever it is adding an IP, it will add its source. It will add the server's IP address, and it will add in the destination port. What it will add is it will add the multicast address. Okay. It will add the IPv4 multicast address. And similarly, in the data link layer, it will add the source port. I'm sorry, it will port address is a wrong word. It will add the MAC address, and the destination address. It will add the multicast address. Now you know that Ethernet is a, and it goes to a through the Ethernet 5. You know, Ethernet is a star topology, which means the packet will always be forwarded to the switch, and once it reaches the switch will have, like, say, for example, 7 other ECUs connected to it. Let's assume it's an 8-port switch. It will look at it as a multicast address, and based on the multicast address, it will forward the packet to all the other ECUs. It will forward the packet to all the other ECUs to whom he has to be multicasted. Okay, so the data will be forwarded. That's the first step. Now, what happens is all the clients who are part of the multicast address understands that a server has published the service. Okay, the server has published the service. Okay, this is how the server publishes the service. Okay, which is part of the service discovery. Parallelly on the client side. Okay, and the server publishes the service. Most important is the server will publish its service irrespective of the client identity, because it does not know the destination address of the client. It's not like CAN where you have a message ID and you have a broadcast, so it is forwarded to all. No, you need to have the source address and the destination address. The source address of the server is its server's source address, server source IP address, destination address is multicast IP address. Similarly, source hardware address is server's hardware address. Destination is destination MAC address. It will put the broadcast address. I'm sorry, it will put the multicast address. Now all the clients have, like, say, received it. Similarly, the client will also initiate the service discovery like a similar way how it added. It will add the multicast address and it will do it. Now, when the client is looking for this who's publishing this service, when this particular server has published its service and it's available, this Ethernet packet, it's available with the client will open the packet. The client will understand that, okay, there is this particular server publishing the service. So how does the client identify? It will look at the source address of the packet. The source address of the packet is the server's source address. Both MAC and IP. Now, the client knows to subscribe to the service. How will he know? He will, like, say, send a request to the server with the service ID, with the server's MAC address and the client MAC address, with the server IP address and port address, with the server IP address and MAC IP address, because it has all the data, right? When the server sends the packet, it used a multicast, but when the client, now, because it captured it from that multicast packet, what is the source address of the server? Now, when it is sending the packet, it will, in the source, he will put his address, and in the destination, he will add the server's address. Okay, and send it. Now, a handshake between the client and the server happens. After this handshake happens, the service discovery phase is over. Okay, this is how service discovery happens. Okay, and in the service discovery, we use this particular service discovery frame format where every service is always associated with the service ID and an instance ID. and it publishes the service. The server publishes the service using multicast address, and the client understands this because he is part of the multicast address, and he will capture the service address from the multicast packet, and he will request the client server, and a handshake happens, and then they start talking in one of the techniques. They could use even group methods or getter setter fields, and they will start talking. Okay, so this is a classic thing that we're going to do. We're going to have a radar ECU which is capturing the distance, and we are going to have an adaptive cross control ECU who's going to, like, say, subscribe to the service, and he's going to do it. So we're going to talk about two techniques now. We're going to just focus on two techniques for lack of time. One is we're going to show how we establish communication service discovery. That's the first thing. Okay. Step two is after you do the service discovery, what we do is we do event method. We subscribe to an event, and we see how this, whenever the event is subscribed, you get notifications. We'll see that. That will be step two. Step three is we will call a request. Okay. We'll ask for a method. So the guy will do some job and he will respond. Okay. So he'll do that. So we'll see these three techniques on the tool. Okay. Creating a server, creating a client, and service discovery. That's step one. Step two, how do I create events, and how do client and server talk over the events kind of communication. Step three, how do client and server going to talk over methods kind of communication. Okay. Okay. In order to make this infrastructure happen, we typically have to have in the real world, what we will have is we will have a HPC which is running, which is a processor-based system running on top of either Linux or QNX, and you will have a service discovery. You will have a client which is running on a microcontroller architecture. But because we don't have enough multiple screens and it's very difficult to show a live demo, we are going to run the system on a HPC, and we are going to use loopback mechanism, and we're going to use terminals. Okay, we're going to have two terminals to differentiate between client and server. Okay, instead of passing it between the microprocessor and the microcontroller, we're going to do a loopback, and we are going to use two terminals to differentiate client and server, just to kind of make it easy for the demonstration process. Okay. So if you have any questions at the moment, I can take those questions, and then probably my colleague Vedashri will, like, say, run you through the demo. Vedashri?
Yes, sir.
Yeah,
Hello.
Vedashri, we can run it in three pieces. We can show them the service discovery phase. How do we create a client? How do we create the server? And how does this process of service discovery happen? Step one, and step
Yes,
two
sir.
is events. Step three is methods. Yeah.
Okay.
Yeah. Meanwhile, if there are any questions, I can take up. I have a few questions on the chat. Probably I can take them. Oh, these are all unable to hear. Can we have access to the video? Yeah, they'll give you access to the videos and all those things later. Yeah.
One question first and foremost is for
Mhm.
the subscribing of any offer service that's sent by
Mhm.
this HPC.
Mhm.
Is the ARP very much necessary before you start subscribing?
Which one? Which one is necessary?
ARP,
What is ARC?
address resolution protocol, because the centralized ECU or the gateway, whatever
I
it is,
agree with you.
and
Okay, the ARP becomes necessary. Okay. What I would try to say is here, just to kind of give you a quick instance, it's not about the some IP protocol that we are talking about. What happens is the ARP protocol is primarily, the central gateway is actually acting as a switch. Okay, the central gateway is acting as a switch. So in order to help you find the destination MAC address, we use the ARP protocol. The central, ECU is actually the, what I will call it, the central gateway, which is acting as a switch, is configured with the ARP protocol. and that in turn helps you find out the destination MAC address. Okay, so it in many of the projects, okay, or in like say almost every project that I've worked on, we found that whenever we are using the central gateway, they use the ARP protocol to build the switch MAC table. Okay, the switch will have to build its table, okay, routing table. In order for the switch to build its routing table, it uses the ARP protocol. Okay, so yes,
Yeah.
it has to be necessary.
No,
But
no,
it has
but
nothing to do with
then,
some IP. That's my only
yeah.
point. Yeah.
No, no, true. But now, with all this systems connected, even if you take the radar, which you're taking as an example,
Mm-hmm.
can we directly subscribe for the offer services provided by the radar using a tester tool, or it needs to be connected via gateway and then only subscribes? That's
Okay.
the whole point.
Yeah, I completely understand this. See, okay, one thing that you need to understand is the if it's for a testing, it's a different scenario. Okay, but when you are using for in a real time, what happens is um, it's a Ethernet protocol. So when I say it's a Ethernet protocol, it's a star topology. And if you look at a star topology, the ECU, whenever it connects, it can only pass the data to the switch, and only the switch can forward the data to the destination ECU. Correct? So
Hmm.
the switch has to be commanded.
Okay. And also one question about this event group notification, where you explain this method of events.
Mhm, mhm,
See, notifications can have to be sent to after the subscription is successful. Notifications have to be sent to the client every 100 milliseconds. Is there a
mhm.
time limit until these notifications will be sent, or is it like it will be sent continuously until the ECU is turned off? What's the life cycle for these notifications to be sent? Or
Correct.
once
Okay,
we.
I'll break this question into two pieces. One notification is associated with the service discovery, and the other notification is associated with subscription of service. So let us say, for example, whenever you're subscribing to a service after the service discovery, okay, the service
Mhm.
discovery has a time to live. Okay, like say, for example, your client should be able to identify the server within a stipulated time. Okay, there's a time to
Mhm.
live for that. Okay, you can't have an infinite time to go and find out who's the server and all those things. You have a limited time on that. That has a time to live. But
Okay.
in terms of service discovery, it necessarily need not have a what do you call time to live. It can go till you turn off the ECU or the operation cycle. Yeah, whatever is the operation cycle, you can keep that.
No, no. I understood your first point, wherein if at all your service is a part of the service discovery, then the time to live, TTL will tell us how much time
No,
it should.
all services
And
will have to be part of the service discovery because the client has to, like, say, discover the server.
Hello.
Yeah,
Hi. Yeah. Yeah. Hello, Curtis.
I'm sorry. Yeah.
Yes, one question from my side. Like, is it possible to include diagnostics, communication, and services also in some IT?
Is it possible to do diagnostics on some IP? Is the question right?
Yeah.
No.
Yes.
Because diagnostics cannot be run on some IP because for any diagnostic protocol to be run, whether it is like say, for instance, CAN or anything, you need a segmentation and reassembly work to be carried out, which will be only routed through DAC. It will not be routed through some IP. Okay.
Okay.
another stupid question.
Hey,
Now,
don't.
these.
All questions are good. Don't worry about. Yeah, yeah. Please.
So one basic question is this:
Mhm.
these services, the offer services that the
I'm sorry, I missed the word, please. The which services?
uh, the offer services, whenever you
Okay.
boot the ECU, the gateway ECU or the radar ECU,
Mm-hmm.
in these services, the service ID can be either an event ID or field ID or a method ID. Is it like the services can be any one of these, or is it like it will be only
It's
this?
independent. It's independent. It's a pretty independent number. So you don't have to associate it with a what do you call, like diagnostics. Let's say, for example, 0x10 is associated with particular. There's nothing like say which says something like that. Okay, it could be something
No,
which is specified by the
no.
OEM, but the
Yeah,
some
yeah, true.
protocol doesn't say that.
My Okay, but my base question is that the service discovery packet, the service ID, is there a field which would tell that it is just a service
Yeah,
or a method
yeah,
ID?
yeah. There is a field. Yes, there is a field.
Oh, okay,
There
fine.
is a
That
field for.
that I know.
Yes,
And
it's not a
generally,
protocol format.
yeah, okay, fine. Thank you.
The service discovery has a protocol format. If at all, I would recommend there's an AutoZar document on, you can just Google service. I mean, some might be a specification. There's an AutoZar document which gives you a clear illustration of how it works.
Okay, thank you.
Okay, so you have a placeholder for where service ID is there on the service discovery phase. Yeah,
Okay, thanks.
thanks, please. All right, so Vedashi, I'll stop sharing. Please take over. And yeah.
Yes. Sir, is my screen is visible?
Yes,
Yes.
it's visible.
Okay. This is the tool generated by the ANSYT. Here,
Vedashri, your screen is a little slow, so maybe you have to go a little slow when you are kind of presenting. Okay.
okay. Okay, sir. Now, tool screen is visible, right? Tool tab.
Yes, Vedashri.
Yes.
Okay, this is the tool. Here, first I will create one project. To create the project, you can click here, or you can go to the files, new. Then I will create the project. Okay, I will select the project. Here in the general, I will select the project and I will give the name as demo project. Okay. Okay. Project, and the name is demo project. Okay. And now I am not using the default one. I will choose the location of the project. So you can select any path. I will just create. I have already one demo project. Okay, I will create one more folder. Okay. Now I selected the demo project. I will just select this path. Then click on finish. Now the project is created. Inside that I will create one simulation project. For that, right click on the project and then go to the new, go to others. Then here I'm choosing the model creation wizard. On the model creation wizard, I am selecting the SumIP model. Okay, and then click on next. Here I will give the simulation project name as a demo project. Demo data sim. Okay, I will click on next. Here I will select the some IP configuration. Means others also will work, but this some IP configuration have entire thing like client, events, services. So I am choosing the some IP configuration as a model object, and then click on finish. Now, if defaultly the graphical editor is opened in my case, but if you are not getting the graphical view editor, just right click on the demo, then go to the new, sorry, open with, go to open with, and here I will choose the graphical editor, SumIP configuration graphical editor. Now you will get the graphical editor like this. Then if you click on this, I will just maximize it. In the right hand side, you will get the different elements we will use in the SumIP. Here we have three different elements, like first one contain this is the devices, like in the SumIP we will use client server as a device. And then we have SumIP services. Here we have the SumIP service, and yeah, if we want to create some events, means we will use the SumIP event. And then we have different connections. Here we have two different connections. Request response connection means the client will request, based on the request the server will respond back. That time, for that technique we will use the request response connection. And subscribe notification means the client will subscribe to that particular event, and then it will get the data, maybe periodically or once the data changes. We'll uh, start the example, then we'll get to know. Now I will take one server. To take the server, this is the graphical editor place, like we need to place everything inside this. Just click on which one you want to take, and just drag it and drop it here. Then I will create one. I have one server and I need one client, correct? First I will show request response simple method. Okay, and I have one server and one client. I will just create one service inside the server. You can you can able to create multiple services. For now I will just create one uh, simple service. Inside the service, I created one service. Just minimize. If you see here, we have the properties view here. Okay, this is our client, right? If I click on the service server, the server related properties we can able to edit it here in the properties view. First I will change the name of the server. I will give the name as my server. Okay, after that, inside the service I will give this name as
you can keep it radar.
Okay,
And the client as ACC.
Okay. Okay. Client name is ACC. Okay. Now, see here, we have the another fields also for device ID and IP address, multicast. We can able to fill these things. If we fill these things, we will get a JSON file. But for now, today demo, I'm showing in a loop back. So I'm not creating any. I'm not mentioning anything in the remaining fields. Okay. After that, in the client side also. Okay, I'm just changed the name. Now if you click on the service, here service ID, method ID we need to fill. Okay, first I will fill the service ID. These are like mandatory. Once you created the service, you should need to create the service ID. I will give 1 2 3 4. Okay, service ID and instance ID. And okay, now I created the instance ID and the service ID. Now I am using the request response. It's a method, so I will use the method. So I am creating one method ID. Okay, now I will use the request response connection. Okay, for that I will choose the in the connections, I choose the request response connection and click on the client. Once you selected the connection, if you click on means the client should connect to server, correct? If you click on server or somewhere else, it won't come. If you click on client, it will start. Okay, after that also you should select the service. If you created multiple services, means you should properly match the which server you need, like that, which service the client is requesting for which service, like that. Okay, now I created only one service. I'm just connecting with that service. Okay, and if you I will change the service name also, like distance measurement. For now I will just give the name as service, because once I get the output, I want to show you where it is telling, where it is coming in the service output. Service or my service I will give. Okay. Okay, now I created one client. After once you connected the once you select the uh, any connections, it will, you can't able to select anything. So you just select the select in the device, then you can able to select it. I will just generate the code now. After giving every fields, I will just give the to generate the code, just right click on the empty field. I will just save this, generate. Then I will choose the folder. Okay, demo project, open. Now you have, I will just refresh the project. For that, right click on the project and refresh. Now if you see here, the source and the CMake file is generated. If you see the source file, two CPP files will generate, because we create one is for server side, server related CPP, server radar CPP, and another one is for client. Okay, now will after generating the code, we need to write the logic. But for today's demo, I'm just showing default logic. Okay, now I will just create one build folder inside the project. New folder. Here I will give the name as build. Okay, now build folder is created here. Now inside the I'm just opening this build folder in the local terminal. Show in the local terminal. Right click on the build and show in the local terminal. I will select the terminal. See, this is our terminal. Just I will start build the project. Okay, now okay, now build is completed. I will just open the one more, clear it. Okay, now I will open one more terminal from the build itself. I will just maximize it. If you see here, I have two terminals. Okay, from the same directory, I have two terminals. From the first terminal, I will run the server, and from the second terminal, I will run the client. Before starting the server, I will just run the client. We'll check how it will. Client.acc, correct? This is the executable name. I will just run the client. See here, first step, the client will initialize and initialize the application, correct? It's initializing the application. Then it is checking for the availability of the service, correct? But the server is not started, so this is my service, correct? We created one service with the name my service is not available, like that client is telling my service is not available, so it is not sending any request. Okay, then I will just stop it. Clear. Once again, I'm just starting the client itself. Okay, now it is telling there is no availability of the service. Just I will start the server similarly in the another terminal. Okay, I will start the radar server. See here, if you see here, it's available. Here it is. It's, see here, it's available. Like once the server started, it start offering the service. Like after that, I will show you here. See here, it's offering. So it is telling my service is available now, like that. Okay, once it's available, it send the client sends the request. Like here the default logic is like whatever the client will send, that the server will reverse it and send it back. Okay, now the client is sending, see here, server is telling I received the message. This is our message. This is the message received by the client. Like this, the client is requesting, the request message is 0 to 9. Okay, now the server will reverse this data, like 9 to 0, and send it back to same client. We'll check in the client side. See here, it's reversed, and here in the client side we are receiving that data, okay, from the my service service. Okay, this is the simple request response application. Now I will show you the I will just close the terminals. Okay, now I will create one more client. That client will use the subscribe notification method. Like first I will create one client. For this one I need to give the name like fusion. Okay, now I created one client, and for if I want to use the notifications, I need to create one event. For that I will choose the event and I will create the event here inside the server. And I will change the name as front object distance. Okay, okay, front object distance. Now I created one object here. Once I created the event, I need to create the event ID. I will give 9856. Okay, and then once I create the events, you can create multiple events similarly, and we need to make one group. For that I will give the event group ID. Now I created only one. For that I am just creating one group ID. Okay, after this I will just select the service. Here we created only one service, correct? So it is showing here only one service with the name my service. If you created multiple services, it will give the list of the service. Among those services we need to choose this event is belongs to which service, like that. Okay, now I will just change this service name as distance measurement distance like that. I will give the name, and I will map the event. If you click on the event property will open here. If you click on the after clicking the after selecting the event, I'm mapping that event with the distance service. Okay, now I selected the service. Then next, here the notification type we need to choose. Here Karthik sir already explained you, like here the data may be coming periodically, or maybe once the data changes, that time the server will notify. Okay, you can choose either the method. For demo I am choosing the periodic. Okay, once you choose the periodic, we need to mention the time. For the time I will choose 500 milliseconds. Okay, it's in a milliseconds. So I am writing 500. Then I need to this connection is empty. Okay, now I will choose the subscribe notification connection with the second client. I will choose second client and the event. If you choose the service, it won't map. It will map with event. Okay, after that, now I created one event. Okay, after that, inside the event, the client, I will also set the payload here. If you see, I will just give the payload as 12. Okay, then means this data 12, I need it periodically every 500 milliseconds. Okay, uh, I want the data like this. Okay, for subscription, once the client is subscribed to that particular event, then that event will the server will send that as a notification every 500 milliseconds. Okay, now I will save the changes, and then I will just generate the code. For that, if you select something, you can't able to generate. So you just select the editor, then click on the generate some IP application code. Here again I need to select the demo project. Okay, now I will just refresh it. See, if you observe the source file, you now we have 3 CPP files. Previously we have only 2 CPP files. One is for server and another one is for CCC ACC client. But now one more CPP file is generated, that is for Fusion, and the server code is also updated in the background. Okay, and CMake file will also update. Now I will just open the build from the local terminal. Okay, now I will again the code is updated, so I am just building once again. Okay, okay, now I have only one terminal. I will just open the one more terminal from the build. Again right click on the build and show in local terminal. I will choose the terminal. I will just maximize the terminal. See, here we have 2 terminals. From the second terminal, I will just start the client. Now if you see here, we have 3 executables. One is for radar, one is for fusion, and another one is for ACC. Now we'll run the radar and the fusion. Okay, okay, now I will run the okay. Now I will just start the fusion, but the server is not available. Correct. So it is not get started. Once I start the server, I will start the server. See here, subscription happens. After subscription acknowledgement you are getting. Every 500 milliseconds, I am getting the notification. I will just stop the notification. I am just stopping the terminal to observe the communication. If you see here, once it's once it get the offers, then it is telling the client is telling this distance server is available, service is available, like that. After that, it registered for that particular event. After that, it subscribed to that event. Then once it's subscribed, it is getting the subscription acknowledgement also. And then every 500 milliseconds it is getting the payload. Hello. Hello.
Yes,
Yeah,
yes.
you are.
Okay. This is the subscription and notification mechanism. Okay.
So, since you have used the interface LO, what is the MAC address, IP address, and all, if that's been used by the server and the client here? Now, the radar, which is the server, I know it's multicast, but it will be taken automatically whatever your
Okay.
Linux machine is using.
Here for
No,
demo,
they
today
have the
demo, we are using
IP
loopback.
address is there, right?
IP address is there, but I didn't fill the fields like multicast IP address and all. I didn't fill the. It means today for demo, I'm using the loopback.
Okay, so the Linux species loopback IP address has been used then.
The default JSON we are using. If you fill these fields, you will get the JSON file also here inside the source.
Okay.
Okay. Now we'll check whether both the clients started at us. Means I will start ACC also with Fusion also. The server will respond. How it is respond, we'll check. Okay. For that, I will just open the terminal once again. Now I will open 3 terminals. Okay. Now in the first terminal, I will start the ACC client. Okay. can I start or will start once? 1 second. I will just write it everything. The next client Fusion. Okay. The last terminal will start the server. Okay. First I will start the ACC. If you observe here, there is no response because the server is not started. If you start the server, see here, you received the response. Okay. Now in between, I will start the Fusion client. See here, I am getting the data every 500 milliseconds. If you want to check any possibilities, I will show like if we start first, we need to start server or anything like that. Okay, now I will just start the ACC client fusion, and then server. Okay, now I will start the fusion first. Okay, then I will start the server. Now you are getting the data every 500 milliseconds. Correct. In between, I will send the another client, ACC client is requesting for the data. I will just start the client ACC. See, you are getting the response, and still you are getting the data in notification also.
That
The
means it is not disturbing these two processes, right?
Yeah.
Whatever it is coming, yeah, got it.
At the
And
same
one
time,
more
it can just
point, we
provide
want
the
to
data.
change it. Okay.
Anyone?
Hello.
Yeah.
Yeah, at a time it can serve both the client.
Yeah, it's a parallel processing like that.
Yeah. So my question is, can we see here the multiple server and the client, one
Multiple
client?
server with one client.
Yeah.
We can.
Like how a handshake is happening, that can we check?
Once it's connecting with the another, like here. Okay, you want to just tell me the requirement. His time is okay. Only 15 minutes is remaining.
Yeah, it's okay for me.
Hello, sir.
Yeah, Vidashri.
Sir, can we continue? Like.
No, I think what we can do is we have a limited time on the webinar. We can like say stop here. Okay. So this is a answer tool which we are kind of publishing for the market. You can write to us if at all you want to like say do something on some IP for a POC, or you want to like say do a Linux based some IP implementation. You can definitely write to us. We can also customize the tool for your requirement. Okay. So we can do that. And you can let us know. You can just write to us or call Bhishma. We can even take you through a guided tour on what you want to do. For lack of time, we'll just kind of close it. Okay.
This Eclipse is a open
any
source
questions?
tool,
Yes.
or
Yes. Sorry.
This Eclipse is a open source tool, or
No. Eclipse is the IDE. This is
okay.
an answer tool. Okay. This tool is built on top of Eclipse.
Okay.
Okay. This whenever you did this subscribe notification, the event ID was seen in this. I saw the service ID and this in the trace. And can we get the Wireshark logs for this just to understand the flow?
We can do that. Yeah, we can do that. You can just write to us. We'll send you whatever you need. Just in 1 day's time, we'll send it across. Okay.
Yeah.
Sure.
Yeah, Karthik, one question.
Yeah, please.
Yeah, so like take example, this method ID and service ID. This ID will be assigned by OEMs, right?
Correct.
And this will be part of ARXML file, or which?
It will be part of the ARXML file. Yes, exactly.
Okay. Yeah. Okay.
These days they call it as FibX.
It depends upon like say where you are working.
Okay.
Yeah.
Hello.
Yeah.
Hello, Karthik. I have one doubt. If we have an ECU, if we have multiple services, do we have arbitration in services also?
You have multiple services. No, this is a one-to-one protocol. Ethernet is a one-to-one protocol.
Okay, so if my multiple, so if there is a need that we have two or more services are going, there is no thing like arbitration.
What do you mean by arbitration?
Can you
which
please
will win
repeat?
the bus? Arbitration is typically which will win the bus, right? Ethernet has no problem in terms of winning the bus. It has huge bandwidth, so I don't think there will be any necessity also.
I think, Karthik, the question is if multiple services is offered by any ECU,
Okay.
Then how arbitration will happen inside ECU? I think this is the
You mean
question.
which will be sent first and which will be sent next?
Yeah, yeah.
Is that the
Yes,
question?
yes. Yeah.
Okay.
Yes, yes, yes.
Okay, so that is not decided by the what is it called? Here, what I will call it bus arbitration. It is actually done by how you have configured the function. Okay, you have the OS. You would have mapped the functions with OS, right? OS task, right? So that will decide how it has to be done. Okay. Hello, can you hear me?
Hello. Yes, yes,
Yeah,
Karthik.
yeah. So the OS task will be the guy who will be managing this. It will not be either POSIX or even say, for example, auto servers. The way you set the trigger will decide what will be first sent and what will be sent next. The order.
And one more thing is, if we have a model and you have number of inputs, based on what criteria we will decide, like this will go
If you can repeat the question, sorry. If you have.
for event and this will go for method.
Mm-hmm.
For example, if you have a MATLAB model and you have n number of signals with you, based on
Okay.
what criteria we will go like this signal will go for event, this signal will act as a method, like that.
No, that is all an architecture decision. That has nothing to do, like say, defined by the software or the tool or anything related to that. That's all like a requirement and decision.
It's like based on
Usually,
your use case.
okay, so even for that method, for that matter, even like say, for example, you're subscribing to an event, how the event has to be qualified, whether it's periodic or like say updation, all those things, even that is not, that's a requirement. There is nothing to the protocol per se does not define all these things. Okay.
Hi Karthik, I have a question. During the connection, um, I saw that the client or the server is getting connected to the routing manager D, right? That is nothing but some IP daemon, correct? So could you give some information on that? Is it one some IP daemon for the entire connection, or if there are multiple ACOs, would there be
It's service
multiple
discovery.
daemon?
It's service discovery. So let's say, for example, it actually depends upon the service. It is associated with the service. So let us say, for example, there is your client is like say trying to kind of subscribe to like say 10 services, or if your client requires some 10 services to be processed, let's assume, then he has to discover all the 10 services. Similarly, the server who is like say what do you call publishing, okay, the service, he also has to publish all the services. So it has to be mutual, and that is done over UDP protocol. It's light.
Okay.
Yeah.
So you mean to say there are three ACOs, out of which three, in your example, there were two ACOs which were
Okay, let's
offering
assume even if you have three issues, let's
service.
assume, yeah, let's go for three issues, okay. And let's say, for example, each of them are like say want to have one
There
particular say 1010.
will
Let's
be
assume put a
two
number
some
to it.
IP and the one the consumer will be using, will be just connecting to this daemons. Maybe if can you
Your voice is not clear. Actually, it's breaking. Bhishma, you are able to hear it?
No, Karthik, it's
your
not clear,
PPT
Karthik.
where you
It's not
had that
clear.
three issues
No, we didn't.
switched,
Okay.
it would be easy to
Can
understand.
you open the picture? I think
Possible.
he wants to open the picture.
Can I run this one? Like I added one more new
Hello?
client.
Yeah, you can run that. Yes.
Am I clear now?
I didn't hear
Yeah.
anything. Yeah, now you're clear. Voice is clear.
I saw an example in the PPT of three ECOs. Could you explain that?
Again, your voice is breaking.
I'm really sorry, team. I have to
Where
step
is
out for
providing the
another
services,
meeting.
right? And ECC and the Fusion are the
Correct.
client.
ICC Fusion.
So
Yeah.
just
Yeah.
consume.
I don't know what is happening. Your
voice is again
Your
breaking.
voice is not clear at all.
The radar ECU here, if we consider. Okay. I'm not sure what is the problem. Is it better?
It's better, but as you speak, it just vanishes. Are you speaking? Ashin Mushtia. Tim, I'm sorry, I have to leave for another meeting. Please write to us. Whatever is your queries, we'll definitely reply to you by tomorrow if you write to us today. It's been really wonderful meeting you again. We have, like say, had some good 6 webinars on Ethernet. Thank you so much for your time. I hope it's useful and wish all the very
I don't
best.
know what is the problem.
Yeah. Please write to
Thank
us.
you, guys.
We will like say reply. We can
Yes,
send
Karthik,
some
we are
screenshots.
running out of time for more than 30 minutes now. So we will wind up today.
We have, you can also have, you can write to us. We can also give you access to the tool. So we can do that as well. Okay. Yeah. This tool is built for the market. So we can help you set up the system also. Thanks.
Thanks, Karthik. Thanks,
Thanks.
Vedashri.
Thanks,
Thank
man.
you.
Thank you.
Thanks,
The
Vedashri.
last one, I need to show this one.
Are you presenting something or can we
No,
wind?
sir. Like someone asked this parallel how it is processing going on.
Yeah.
We'll wind up.
Okay.
Hello, sir.
Yeah,
If you
we
have
are-
prepared, you can show.
Okay, I will.
This new client is of what type? Is it a request response or a subscribe notify? Hello?
Divyasri, you are in mute, I think.
Hello.
Yeah.
Sorry.
This
Sir,
new thing that you have created is what? Subscribe
subscribe
notify?
notify. Yeah, subscribe
Okay.
notification. If you observe here, this is subscribe notification line. Okay, both are asking for same data at both are asking at the 500 milliseconds. Okay, now if you observe here, every 500 milliseconds, this is a new one, new client terminal. This is getting the data every 500 milliseconds, and here also this is old one. This is also getting the data every 500 milliseconds.
And how are you differentiating between these two event IDs in the? Can we go to the
Okay, I will
simulation
just
and
start it once again. Okay, this is new client. Okay, I will just start the new client. See here, you are getting the data. I will start the old one. Genex client fusion, correct? That's the old one. I will start this one. This is also getting the data. Hello?
hello? Can we go to the stimulation and show us what is the event IDs that you have linked to both these? Yeah, there. Yes, the new client. How is it linked to the events?
Based on this subscription notification line.
And in
Inside
the
the,
properties, in the
okay.
properties.
See here, this event is periodically 500 seconds.
Okay.
The client is this new client came here. Just I added one client and a line, subscribe notification line.
And the new client ID is linked to the front object event, or how? Or
New
how is the new client, how is the linking done there in the properties? That's an interesting.
Based on this subscribe notification line,
Okay.
this is linked with the element. This element is already linked with the service.
Okay.
Now, based on this line only, we are linking these two.
Okay.
Okay. Thank you. Thank you.
Okay, thank you.
Thank you.
Thank you.
Thank you.
Vedashri, are we done?
Thank you all.
Thank you all.